Hello, dear members. In this discussion, we are going to be looking at volume of cut and fill, and we are going to use a method of prismoidal. So we are going to use prismoidal formula. Now, we have chainage at 0.00. We have the ground level at 107.2 and the formation level or the finished level at 108.00. The chainage 20, we have the ground level at 107.9, 108.00 is the finished level. Up to chainage 120.00, we have the ground level 109.1 and the finished level at 108.00. The ground level is the way the ground exits. Okay, the way the ground exits as per now. But now we are looking at raising this ground to 108. We want to attain a level of 108, and that's where we want to start our constructions from. So that means this is going to include a fill, and where you find that the finish level is lower than, is higher than the ground level, then we shall be able to do the cut. Okay, I'm saying if we find that the finish level is lower than the ground level, we shall be doing the filling. If we shall be doing the cutting. If we find that the finish level is higher than the ground level, we shall be doing what? We shall be doing filling of the ground level to reach the finished level. So FL is the same as saying finished level, or what others call the formation level. Now, so to get the difference or the depth that we are interested in, we shall do the formation level minus ground level. And what is going to be the difference here? This is, if I do the subtraction here, this is 0.8. And if I subtract this minus that, I have 0.1. If I subtract this, I have 0.0. If I subtract the 2, I'll have negative 0.8. So this represents a cut, and this represents a fill. So from here, actually up to there, we are talking about fill. And from here, let us see, what is this one? This is negative 1.0. What is this? This is negative 2.8. If I do a subtraction here, this is negative 1.10. So this is representing a cut. In other words, I have the ground level like this, and I have what? I have the finished level like this. So what does this mean? The finished level is lower than the ground level. So what do? I need to cut the ground level in order to reach the finished level. That's why we are finding that where we have a negative difference between FL and GL is representing a cut, and where the positive exists, we have what we call a fill. Like here, this is going to be a positive because the FL is higher than the ground level. So let's look at how we can determine the areas at each of those cross sections. So what is going to be the area here? So in here, it was provided that the top width of the embankment that we are looking at is B is equal to 10, and the side slopes is S equal to 2. So if we are talking about an embankment that has a trapezoidal section, then this is going to be 2 to 1, 2 to 1. And the top here is going to be 10 meters. So what is the area of each of those cross sections as we move away from the first section? So it is going to be BD plus what? Plus SD squared, whereby D is the depth at each section. So the area that we're talking about is going to be BD plus SD squared. Remember, this is the same as 10 times D plus S, which is 2 times D squared, because 10 is a constant and S is a constant. So when we substitute in here, this is going to be 0.8 times 10 plus 2 times 0.8 squared. This is going to be 8, okay? 8 plus 0.64 times 2, and that gives you 0. 0 point what? This is going to give you 1.28 plus 8, that gives you 9.28. So if we substitute in 0.1, it's going to give us 1.02. When we substitute in 0, so area also becomes 0.00. When you substitute in 0.8, what do we get? We also get 9.28. But remember, the other areas are negatives. But let's proceed. So we put in 1. So at 1, we are going to get 12.00. When we substitute in 2.8, again, we have 43.68. When we substitute in 1.1, we have 13.42. So what is the distance between each of the 2 points? In other words, if we are talking about sections, so each of those sections, okay, each of those sections is at what distance from each other? The distance, as we earlier on see, so it was at a distance of, the distance is 20, because the chainage is 20. So also the next one is at 20. So we shall put 20, 20, okay, 20, 20, 20, 20, 20. Now, the other thing that we need to look at is to understand now the volume. We are going to put column for the volume, and here we are going to look at which one is a cut. Remember, we had a cut and a fill. So we said we had area A1, A2, A3. So when we reach here at 0, 0, okay, this is going to be our area A1. Then we have A2, we have A3. So we use the other formula of prismoidal formula, L out of 3 into A1 plus A3 plus A2 is even, so we shall say 4 times A2, because we already know that the formula according to trapezoidal method is A1 plus AN, okay, into, plus 4 into whatever is even, okay, plus 2 into whatever is odd, A3 plus dash dash up to AN minus 2. And then we close. So what does that mean? I'm going to look at what is here. This is going to be 20 out of 3 into area, which is 9.28, plus the area here, which is 0, now plus 4 times 1.02. 1.02 is here. So what we get is is going to be for the fill, because if you check on what we have up here, the fill starts from here up to there. So what we get here, we get 89.0667. That is in cubic meters. Let's look at the other part of fill. So fill starts also from here, 0, 0, up to there. So let us say our A1 starts from there, A2, A3, A4, A5, meaning that according to the prismoidal formula, that volume V2 is going to be A1 plus A5 plus now 4 of whatever is even. That is going to be A2, which is 9.28 plus A4, which is 43.68 plus 2 into whatever is odd, and that's going to be A3, which is 12.0. This gives me volume equivalent to 1661.733 cubic meters. So we put 1661.733, and that is in cubic meters. So the volume of cut is going to be 1661.73 cubic meters. Volume of fill is going to be 89.0667 cubic meters. Then we will have solved the problem, because we are told to calculate the volume of cut and fill. Given those changes, we are provided with the ground level, we are provided with the finish levels, and then we are provided with the slope of the embankment that we are looking at and the top width of the same.